Hi everyone, my name is Maria. I'm a PhD candidate in economics at the University of Birmingham in UK. And today I'm going to talk to you about forest fires in Australia, or more specifically, about the near-miss effect of forest fires in Western Australia. So using data from Western Australia. I will explain later on what a near-miss effect is. For now, I want you to keep in mind that forest fires and forests in general are becoming increasingly important because global warming is increasing the likelihood of forest fires. And when a forest fire occurs, it contributes to the biodiversity crisis because it disrupts or destroys the habitat for many plant and animal species. So it's important to study this. Okay, now I'm going to talk about forest fire disasters then. Forest fire disasters can be experienced either as a direct hit or as a near miss. If we experience a forest fire disaster as a direct hit, we would experience damage. And if we experienced it as a near miss, then we would not experience any damage. So if we are talking about a house, a property, for example, you can see that a house in the direct hit area is burnt, and the house in a near miss area is not burnt. So a near miss event is one where damage outcomes could have happened, but by chance did not, meaning that there was nothing preventing the fire from continuing this path and burning the house, but it simply stopped there. Now, what they both have in common is information effects. So in both of them, you can witness damage, and in both of them, you can receive warnings, for example, emergency warning alerts during the fire. This could be messages asking you to take some action to protect your life or your house, for example. Okay, now that you know what a near-miss event is, I can talk to you about what is a near-miss effect. So a near-miss effect of a forest fire is simply the impact of a near-miss event in an outcome of interest. So there can be many outcomes of interest. For example, a near-miss event can trigger local authorities to push for more investment on preventative measures, such as forest management practices. It can also trigger mental health impacts from trauma. So from the trauma of seeing your house being lost or losing a loved one, or simply having felt your life was at risk. And it can also trigger changes in safety preferences. So you might be wondering, how can economics serve this purpose? And the answer is by looking at market choices. So we can look at the near-miss effect of forest fires as the changes in safety preferences that are revealed through market choices. And for that, we rely on one economist, Rosen, which in 1974 designed the hedonic price method. So the idea behind the hedonic price method is that a good has some value depending on the attributes it possesses, which give utility or satisfaction to consumers, to the people who consume the good. Now, deciding where to live is one of the most important choices in life, and it takes into account several attributes of the property. So, for example, this is a house which has a value, and there are three main categories which explain its value. The first one is structural attributes. So for example, building materials, parking spaces, etc. The second one is neighborhood attributes. For example, distance to the nearest school, supermarket, city center, bus stop, train stop, etc. And then environmental attributes. This could be distance to the nearest forest, beach, park, and there are many, and one of them is the risk of wildfires. So you decide where to live or not, depending on many aspects of the property, and one of them could be your perception on how at risk you are from wildfires in that location. So a buyer and a seller meet and they agree a price, an equilibrium price, a market price, which is the price we see as the market sale price. And this price is a function of neighborhood, environmental, and structural attributes. Now, we've talked about market choices. Now, the next step is to talk about how can we capture this change in safety preferences. Well, the literature states that only disasters, well, not only, but disasters can alter risk perception. And by altering risk perception, they alter safety preferences as well. So we need to look at prices or market sale prices of houses before and after the forest fire disaster. However, how do we know that this change, this before and after change, is explained by the forest fire disaster itself and not by something else? The first or the simplest way to answer this question is to ask yourself, why would it not be? And the answer is that there could be other events that could be explaining changes in price. For example, there could be floods in the same area or an insect infestation in the forest near that area. So we need to introduce treatment and control groups. The idea behind introducing these treatment and control groups is that we have properties or houses that experienced the fire, and we have properties or houses that did not experience the fire, but experienced everything else that was experienced by properties in the treatment group. So the only difference between properties in the treatment and the control group is the experience of the forest fire itself. And we've talked about the near miss effect and how it can be experienced in two different ways. So we will have two treatments, and therefore two treatment groups and two control groups. The first treatment is distance to the burn scar, and by this we are aiming to capture witnessing damage. So the closer you are, the closer a property is from the burn scar, the more likelihood it is, or the more likelihood that the household in this property has experienced or witnessed damage. And the second treatment is whether or not the household is living in a property that received emergency warning alerts. So messages telling them by radio or by phone to take some immediate action to protect their life or their property. So we've said that we are using two treatments. The first step then is to assign observations to treatment and control groups. And I'm going to do it in the context of an impact evaluation method called differencing differences. Don't get too lost with the names or any technical aspects. I'm just going to try to explain the logic behind this method. So the first step is to assign observations to treatment and control groups. To explain this, I'm going to use as an example treatment number 1, which is the distance between a property and the burn scar. But you can figure out how it would be with the second treatment. It's the same logic, really. So we have a fire here, a forest fire, and the fire spread in this direction and it contained this area. The black houses are the burnt houses, so this is the direct hit area, and the red houses are those in the near miss area, so those within 5 kilometers of the burn scar. Then the blue houses are those beyond the 5 kilometers of the burn scar, so these belong to the control group. Next step is to implement the difference in difference method. DID, or difference in differences, is very useful for comparing outcomes of a population that experienced the fire and a population that didn't experience the fire. Then we have two differences. Difference A, which is the before and after comparison for the treatment group and difference B, which is the before and after comparison for the control group. What we are comparing here is the sale prices. So the sale price of the house before the fire with the sale price of the house after the fire. Now, because we are comparing property with itself, we are comparing, for example, this property, which has 3 bathrooms, and this property, which is the same, then it also has 3 bathrooms. That means that any change in price in this property is not explained by the number of bathrooms it has. So any time constant factor here in these properties is not explaining any change in price. That's the key idea behind these differences here, A and B. And now remember that the only difference between the treatment and the control group is that the treatment group experienced the forest fire disaster as a near-miss event, and the control group didn't experience it at all because it was too far away. So this difference A, the number we get is, or the change in price we get, is attributable to time varying factors in general. That includes the forest fire, any flood that occurred, etc. And this difference B, the change in price we get, is attributable to time varying factors that are different to the forest fire event. So this includes any flood that occurred in that area and also in this area, right? So when you subtract A from B, what you get is the change in price that is attributable to the forest fire event only. So this is the treatment effect. I know this slide looks very daunting and it looks like it's very complicated, but I assure you it's not. Nevertheless, I did want to keep these equations to show you how an econometrics equation looks like. But what I really want to say here are 2 things. First, that we are going to estimate 2 equations. In the first one, we are only considering treatment number 1, which is the distance to the burn scar, and the near-miss effect is this parameter phi. So this is what we are looking for. And on the second equation, we're going to include both treatments, the distance to the burn scar and whether or not the property is in an area that received emergency warning alerts. So here we have 2 near-miss effects, phi1 and phi2, which we are interested in. Now I'm going to talk about Western Australia. So this is a map of Western Australia. You have you can see the forestry types that are in Western Australia. Most of them are in the green color, meaning that most of the forests in Western Australia are eucalypt forests. These green dots are the residential properties that were sold between 2010 and 2019. And there's a pink area, which is the bushfire prone area, which simply signifies areas that are at greater risk of wildfires. And as you can see, most of Western Australia is at risk of wildfires. And then here, this is the ignition point of a fire, which I'll talk about later. But what is important to see is that there are many properties here in the southwest. They are very near the eucalypt forests, also near the beach or the coastal area. And these properties are also in bushfire prone areas, so in areas at risk of wildfires. Eucalypt forests or eucalypts are native to Australia. The most common in Western Australia are the Yarra and the Karri, and they are highly flammable because of their oil-filled leaves, the leaf litter that they leave behind, and the peeling bark. So oil is of course very flammable, and then the peeling bark also makes it very flammable because the bark peels off, it starts to burn, and then it spreads to other trees or to other structures, through an ember attack. And this process is called spotting. So the peeling bark flies away with the wind to a different tree or a different structure, and it ignites this different tree or this structure. And although eucalypts are very flammable, they are also adapted to survive. So you can see how easily they recover from fire. They are also very valuable for biodiversity and for timber. So the koala feeds on eucalypt leaves only, and the eucalypt forests in general are a habitat for many animal and plant species, including, for example, the white-plumed honeyeater here, or the Carnaby's black cockatoo. And here's an example of a timber product made from the Yarra eucalypt. Now, the forest fire disaster that I will use for my research or in this presentation is the Varuna fire of 2016. So on the 5th of January of 2016, there was a lightning strike south of Dwelling Up right here, and that generated a fire which was detected on the 6th of January of 2016. It was quite a disaster. More than 69,000 hectares were burned, 2 people died, 181 dwellings were destroyed, and more than 3,000 hectares of forest plantations were lost. Here you can see some news paper headlines from that time to give you an idea of the scale of the disaster. Now I'm going to analyze the Varuna fire disaster as a near-miss event. So first, I need to identify the properties, the observations that are in my treatment and my control group areas. So this one right here, this dark red is the burn scar of the Varuna fire. So that's the direct hit area. This is the ignition point of the fire. And immediately next to it is a 5-kilometer buffer. So that's my first treatment, distance to the burn scar. Any property, so any green dot that falls within this distance band, this orangey distance band, is part of my treatment group. And any property that falls outside, so for example, these properties right here, are part of my control group. Then the next treatment is whether or not the property is in a town that received emergency warning alerts. These emergency warning alerts were issued on the 6th and 7th of January, so in the first 2 days of the fire, and they were emergency. The main message was take immediate action to survive because you will be impacted by the fire. And the towns that received these warnings are these in yellow. These are the boundaries of the towns: Waruna, Preston Beach, etc. So any property that falls within these town boundaries are part of my treatment group for this treatment number 2. And any property that falls outside are part of my control group. So for example, these properties here. Now it's important to note that not all households that are near the burn scar, so not all households within 5 kilometers from the burn scar, receive these warnings. So this generates some variation. The data I'm going to use, well, all I want to really point out here is that I am considering the structural, neighborhood, and environmental attributes of the property, and I am using a sample of 51,000 properties that were sold between 2010 and 2019. So any property that was sold between 2010 and the 5th of January of 2016 is in the before period. So they were sold before the fire. And any property that was sold from the 6th of January of 2016 up until the 31st of December of 2019 is part of the after period. So what results do I get? remember phi is a near-miss effect. And when I only use this treatment, distance to the burn scar, I get phi equal, statistically equal to 0, meaning that that changes in house prices are not explained by the distance to the burn scar, so are not explained by being in close proximity to the fire area. This would seem to suggest that the Varuna fire did not generate any changes in safety preferences in this near-miss area. However, when I estimate equation 2 and I consider both the distance to the burn scar and the receipt of emergency warning alerts, then I get a different result. Phi1, which is the near-miss effect as a distance to the burn scar, is positive, so we have a positive near-miss effect of 8% for properties within 5 kilometers, meaning that the house prices increased. The house prices of houses that were within the 5-kilometer distance band increased by 8% after the forest fire event. And Phi2, the second treatment, is negative of about 6%. So the near-miss effect here is a negative near-miss effect of about 6%, meaning that properties that are within towns that received emergency warning alerts experienced a price discount of about 6% after the forest fire event. So what lessons might we get here? First is that the near-miss experience is explained by much more than the distance to the direct hit area. And we get this lesson from the fact that when we only use the proximity treatment, we do not get any effect. However, when we incorporate a more comprehensive concept or a more comprehensive definition of the near-miss effect by including the receipt of emergency warning alerts, then we do get an effect. The second lesson that we get is that living near a burn scar is not necessarily bad. It sounds terrible, it sounds bad, and it is bad, but however, we can see that we got a positive near-miss effect for the distance to the burn scar in our second equation, meaning that house prices rose about 8% on average for properties within 5 kilometers after the forest fire event. And this might be because the burnt fuel around the property reduces the likelihood of future wildfires. So the less leaves and forest density you have, the less likely it is that there's a future wildfire in that area, because there's nothing else to be burnt. So households seem to perceive this and seem to feel safer, which would explain the house price rise of 8% on average. The third lesson is that emergency warnings may actually be an effective tool for disincentivizing living in risky areas. So apparently, or it seems from our research, from our results, that households seem to feel vulnerable when they receive these warnings, and that would explain the house price decrease by 6% on average, so the negative near-miss effect that we get. Okay, that's it from me. Thank you very much for your attention. I hope you've learned a little bit more about how economics can contribute to the environmental debate and how can forest fires trigger or alter risk perceptions, and how these alterations have an impact on very tangible things such as market choices. I hope you've enjoyed it, and thank you very much again.